Good morning, students. Today we are going to start a new chapter, trigonometry. As you are aware of triangles, angles, so using these angles, triangles, and sides of triangle, we will go to trigonometry. Do you know what is angle? So angle is simply having two lines meeting at a point. One is terminal line and second one initial line. So main thing here in trigonometry, we will discuss the relationship between side length and angles of a triangle. And using these relations, we will solve some expressions, equations, and it will contain some formulas. Here the basic examples I am giving you of expression and equation. As you know, in algebra, algebraic terms are here 4x plus 2y, and this is constant term 14. So expressions are containing numbers, maybe variables also, that is x, y, or maybe it can contain both numbers and variables. On the other hand, equation contain equal sign. If there is no equal sign, that means it is an expression. And if equal sign is there, this is an equation. So this is the simple difference I given you here for understanding. Now we will go to some questions. And in trigonometry, the main important thing is trigonometric ratios. As the name is given, trigonometric ratios. Ratios means what? Means having numerator and denominator. That is the fraction. Here, sine of theta is the ratio of perpendicular of a triangle and hypotenuse of a triangle. In the trigonometric functions or trigonometric ratios, we are using right angle triangle. Right angle triangle, you know, that is one angle 90 degree. And here we used angle theta. This is the perpendicular, we mentioned it as P. And this is the baseline. It is marked as B. Now this is hypotenuse. It is marked as H. Here we are going to read about ratios. Only these sides will be used to find these trigonometric ratios. Here are 6 trigonometric ratios. Number 1, sine of angle of theta. This sine of angle of theta is equals to P by H. That means perpendicular by hypotenuse. And cosine of angle of theta is B by H. This is base and hypotenuse. Tangent of theta is perpendicular by base. And these trigonometric ratios having short form, so that we can directly tell it as sine, cos, tan, cot, say, cosec. So this can be read as sine of angle of theta is equals to P by H. Cosine of angle of theta is equals to B by H. Tan of angle of theta equals to P by B. For remembering this ratio, one of the trick is given. This is P Pandit, P Badri, P Prasad, H Hari, H Hari, B Bol. Means Pandit, Badri, Prasad, Hari Bol. Means Pandit Badri Prasad will be in the numerator, Hari Bol will be in the denominator. And we know sine, cos, tan. These are three important trigonometric functions. So sine of angle of theta will be P by H, cosine of angle of theta B by H, tan of angle of theta will be P by P. That is Pandit Badri Prasad Hari Bol. And using these trigonometric ratios, we can find these functions. These are called reciprocals of the given function. That is cosecant of theta, that is cos of theta, and this is secant of theta, sec of theta. This is cotangent of theta, cot theta. Here this is cosec theta. Cosec theta is reciprocal of sine theta. That means cosec theta can be written as 1 by sine theta. Means reciprocal is your denominator will go to the numerator and numerator will become denominator. This is the change in reciprocal. Here numerator is P, so it becomes denominator, and denominator is H here, it becomes numerator. That's why cosec of theta equals to H by P. Now sec of theta equals to H by B because it is reciprocal of cos theta. This is B by H, it becomes H by B. And cot theta. Cot theta is reciprocal of tan theta. P is numerator, so became denominator. B is denominator, it became here numerator. So these are the reciprocals of given basic trigonometric ratios. According to this triangle, we know Pythagoras theorem. That is P and B. The square of these two sides, that is square of P and square of B, here square of B and square of P means sum of the squares of P and square of B is equal to the square of H. Means sum of the perpendicular and base of a triangle is equal to the square of hypotenuse of a triangle. This is our Pythagoras theorem. These theorem we will use in solving some of the given questions. Here are some given questions you can see. These questions are in triangle ABC. This is a right angle triangle at B. AB is 24 centimeter, BC is 7 centimeter. Now we have to find sine of angle A, cos of angle A, and sine of angle C and cos of angle C. Here, First of all, we will find sine of angle of A and cos of angle of A. The very important thing I want to tell you again, the theta, opposite of angle of theta is this side. Any opposite sides of an angle is always perpendicular. That is, this is the theta angle, and opposite of this angle theta is P, this side. So this will be always perpendicular. So perpendicular depends on the angle theta, which angles we are taking. If the angle is this, then our perpendicular will be this. So opposite of angle theta is always perpendicular. Any side opposite to angle theta is called perpendicular or is taken as perpendicular. This is the angle theta, and opposite of this angle theta, this side and this side is perpendicular P. We will use this in solving this problem. As you know, these are given. We know that this is triangle and this is right angle triangle at B. AB is the side 24 centimeter. BC is 7 centimeter. In order to find AC, we will use Pythagoras theorem. That is, h square is equals to p square plus b square, means AC square, this is h square, is equals to AB square, that is b square, plus p square, that is BC square. This is formula we used here, Pythagoras theorem. After using these values, we will get 625 centimeter, and 625 centimeter square is equals to AC square. When we will move or when we want to find AC, this square will change into root in the right side and it will give it as 25 centimeter, that is square root of 625 is 25 centimeter. This you already read, that is finding of square root in your previous class. So here I am not going to discuss about the square root, direct you can find. So we got all three sides, that is H, and this is our P, this is our B. Now the question is sine of angle of A. Sine of angle of A is what? We know the formula P by H. Here AB is P and H is AC. So P is BC and H is AC. As I already told you that we are taking theta and opposite of angle theta is always perpendicular. So here perpendicular, that is P, is BC. That's why we wrote here BC by AC. Now BC was 7 centimeter here and AC is 25 centimeter. So we got the answer sine of angle of A is equals to 7 by 25. Now cos of angle of A. This will be our AB by AC. Why? Because we know that cos of theta is equals to B, that is base. Base is AB and H, AC. So AB by AC. that is AB is equals to 24 centimeter and EC equals to 25 centimeter. Now we have to find in the question, you see, sin C and cos C. Sin C is what? This is the ratio of perpendicular distance by hypotenuse. And here we are taking angle C. So side opposite to the angle C is AB. That is AB. And hypotenuse is EC. So AB by EC. Now we put the formula or put the value of AB and AC. We got 24 by 25. Now we will find cos C. We know that cos C equals to base by hypotenuse. And base is what? Adjacent side of given angle. So adjacent, this is, we are using angle C, and the adjacent side of angle C is this one. We can't take or opposite sides of angle C, because opposite sides of given angle is always taken as perpendicular. So this is our P and this is our B. And this is H. We know that cos of theta or cos of any angle is equals to base by hypotenuse. Here base is BC. So BC, hypotenuse is AC. So it is written as BC by AC. Now we put the value of BC and AC, that is 7 by 25. So these types we can find the value of all the trigonometric ratios. One more question I will discuss here. You can see this is the given triangle, right angle triangle here at Q, and this is perpendicular distance 12 centimeter. This is hypotenuse 13 centimeter. By looking this figure, you can find other sides because this is right angle triangle, and you know that in right angle triangle we can apply Pythagoras theorem. Applying Pythagoras theorem, you can write it PR square equals to PQ square plus QR square, where PR is hypotenuse, PQ is perpendicular, and QR is base. By solving this equation, we can find QR, and QR is our base. So we got this one side also, B equals to 5 centimeter. And now we have to find the value of tan P minus cot R. Here we have taken angle P. So opposite of angle P will be this side QR. So this will be have as P, and this adjacent side will be have as B. So here tan of angle of P is equals to P by B. That is perpendicular distance QR by base PQ. And we put the value, we got 5 by 12. And second term cot R we have to find. Because the equation is given, expression here, tan P minus cot R we have to find. We already find here tan P is equals to 5 by 12. Now we will find cot R. Cot R will be taken as, first you see in the triangle, we are using this angle R. So opposite of this angle R is this side. So PQ is perpendicular, or it will behave as perpendicular for the given angle. So P equals to 12 centimeter and adjacent side will be 5. B equals to 5 centimeter. And we know that cot of angle of theta or cot of any angle is reciprocal of tan of angle. That means B by P. Here B is our QR and P is our PQ. That is QR by PQ. We put the value of QR and PQ, we got 5 by 12. Now, using this expression, tan P minus cot R, and we put the value of this tan P and cot R. After subtraction, these are the same terms. Subtraction, we got the value 0. So this is the way of solving. How to solve these expressions, and using Pythagoras theorem, which term or which side we will take as perpendicular, that is always considering angles, opposite side is perpendicular, adjacent side is base, the main thing. Okay, one more question I will solve so that everything will be clear for you. Here given sec theta 13 by 12. Calculate all other trigonometric ratios. Sec theta is 13 by 12. We know that sec theta is reciprocal of cos theta. I will show you here. Reciprocal of cos is sec theta. This is B by H. It is H by B. So reciprocal of cos theta is our sec theta. And this is the ratio given. So we don't know what is the actual value of our base or hypotenuse. See here, this is the right angle triangle. Whenever we are using trigonometric ratios, means we will consider a right angle triangle. Here right angle triangle, ABC, we took one of the angle, we took theta, one angle 90 degree. Now sec of angle theta. We know that formula sec of angle of theta is hypotenuse by side adjacent to the theta. Here hypotenuse AC and adjacent side is our AB. So hypotenuse AC, adjacent side is AB. Sec theta value given 13 by 12. Now we will take an integer or ratio or multiple of this ratio K. So AC can be written as 13K, AB can be written as 12K, because we don't know the actual value of base or actual value of hypotenuse. So we took one of the multiple of these ratios, it is K. Now applying the Pythagoras theorem in triangle ABC, we got what? AC square equals to AB square plus BC square here. And AC is how much? This is 13K and AB 12K. So by this formula, we can find BC. Here BC square is equals to 25k square. On applying square root both sides, BC equals to 5k. Now we will use all the trigonometric ratio, that is sine, cos, tan, cot, sec, cosec. Sec is already given, so we will not find it again. We will find only cosec, cot, tan, cos, sine of theta. So sine of angle of theta is P by B, that is perpendicular by hypotenuse P by H. P we know that is the opposite side to angle theta, that is BC, and hypotenuse is EC. We put the value of BC and AC. After solving, we got 5 by 13. And here cos of angle of theta, this is, we know that B by H, B is base, this is side adjacent of angle of theta, and hypotenuse, side adjacent to theta is AB, hypotenuse is EC. Now we put the value, we got the answer 12 by 13. Tan of angle of theta, we know that P by B, where P is perpendicular, that is BC, and P is our AB. So BC by AB, again we put the value here and we got our answer 5 by 12. Now cot of angle theta. Cot of angle of theta, you can directly find reciprocal of tan theta, that is the numerator becomes denominator, that is 12 will be numerator here. So 5 by 12 becomes 12 by 5. Now the last one here, cosec of theta. Cosec of theta, we know the formula. This is reciprocal of sine of angle of theta. So denominator and numerator exchanging will be here. You can directly write 5 by 13 as 13 by 5. So it will give you cosec of theta. So these are the methods or some formulas used for solving these questions. So main is trigonometric ratios we used here. I will summarize these things. So trigonometric ratios, 6 trigonometric ratios we used here. Sine of theta, cos of theta, tan of theta, cosec of theta, sec of theta, cot of theta. So Pandit Badri Prasad Hari Hari Bol. That is P by H, B by H, P by B, like that. You have to remember. And these three, cosec is reciprocal of sine, sec is reciprocal of cosine, cot is reciprocal of tangent. So numerator becomes denominator, denominator becomes numerator, means exchanging of numerator and denominator is taking place here in order to get the value. And one more theorem here we used, Pythagoras theorem, that is the square of the sum of p square, that is perpendicular and base, is equals to the square of hypotenuse. We can also tell the square of hypotenuse is equals to the sum of the square of perpendicular and base. This is the formula we have to remember. Then we can find or we can solve this exercise easily. So you should remember these things. You can solve it easily. Thank you. Tomorrow we will discuss the next questions. Okay.